Okay, I am recording this small lecture, let's call it uh, lecture for now, to explain some things which I did not have time on the lecture itself. Uh, and for those who missed it or did not really understand it uh, properly, I'll try to talk about the depiction of the planes in this case, and then I'll try to show you how they look in 3D, but I might not have time for that. So without further ado, let's just get into it. There are a number of ways to depict a plane. First one, let's say the most common one, it is by having a triangle. So triangle has 3 points, so let's just invent any 3 points, doesn't really matter where they will be aligned, let's say like this. And obviously we need to have its frontal projections as well. Maybe one is there, one is here, and other one is there. Other times you would have coordinates, and you can depict the exact placement for it. And without drawing the triangle 3 points, but these 3 points should not be collinear, which means they should not be aligned on the single um, line. That's the only rule here. So 3 points, when they're fixed in the space, they always show one possible plane taken. You have followed the rule of them not being collinear. So let's name them real quick. All right, and another way, like you can leave it like this, and this already depicts the plane. But to visualize it better, you can have a triangle drawn like this, and it's much easier to visualize like so. You can give it a color, and yeah, this is if there was a triangle or the plate in space and you looked at it from the front, this is what you would see, and if you look at it from the top, this is what you would see. Or just to imagine different, if you're standing in front of it and you shine a torch at it, this is a shadow you will get casted on the wall, and if you were um, shining that same torch from above, that's the shadow you would get on the bottom. So with that out of the way, let's move on to the other methods of depicting a plane. I will be using the same points again, same position of the points. Maybe we are given this kind of points. One of the more common ways is having two intersecting lines. Let's say there are these lines intersecting with one another, but in this case, in order to get another projection, if you're given the frontal one, then you have to build the horizontal projection accordingly, or and vice versa. So once the intersection happens and we know they intersect, we must mark the point of intersection, give it a name, doesn't really matter what it will be, let's call it K. And since point K also belongs to AB, it should also be resting here somewhere, because like I cannot draw a line from coming from point C like anywhere I would like. That's not how it works. So I need to mark this K point down here, and since I know it belongs to both AB and line coming from C, in this case, that's the accurate depiction of line C, and well, or line coming from point C, and therefore accurate depiction of the plane. In this case, the plane is defined two intersecting lines, which is also quite common, as I said. So yeah, this also defines only one existing plane in space. So with that, let's move on to the other one. All right, we are given the same 3 points, and one of the methods is drawing the two parallel lines or set of parallel lines. So if you can use any combination, in this case I went with AB. I could have also taken BC like this. And once you have these sets, at least one set defined, on point A, I should draw a parallel line to this already existing one, which would be like this. You can extend it on the other side, like so. And what do I do here? Well, if line was parallel to this one, it should be parallel to its respective projection down here. So on point A, parallel to this, I will get this line here, like so. And that also depicts the same plane in the space. So this is most common ways of depicting the plane in space. Um, there are other ways. You can have traces, but we'll get to the traces on different lectures. And now these are the oblique planes. Oblique planes are always inclined to all of the projection planes, and this inclination is uh, never 90 degrees. But what happens when you have 90 degrees inclination? Well, you get special placement for the planes, which is either a level plane or the projecting plane. It's really similar to the um, lines which are projecting and level lines, but there is a small difference which I will try to show here. So let's say this is there is nothing depicted here, but once I have just a line drawn like this, and I'm being told this is a plane. Well, pardon me, I do not have the Greek alphabet. Let's just pretend this is Greek alphabet, so bear with me here. And like this, and most of the time, this part will be slightly thicker. And if you see such depiction, and it looks like a line, we call this an edge view of a plane, or simply a projecting location of the plane, or projecting plane. And instead of B would have the Greek alphabet, and it doesn't have um, projection here, because if you could imagine it like this, if you're looking out from the window, uh, it doesn't obscure anything, right? You have a glass, sheet of glass there, but it doesn't obscure whatever is behind it. So therefore this will not have the depiction here. But if there is intersection happening here with another line, yeah, that will be depicted and visibility will be discussed. But that's a topic for another lecture, so we are not going to waste time for that now. So this is just a projecting plane. This is horizontally projecting plane. You can have the same you can have literally the same on other projection planes, like, but obviously the name will be different. This is now a frontally projecting plane, and it also doesn't have horizontal projection. And there is one more plane, which is a level plane, like this. And anything that is depicted or contained on a level plane is always depicted with its true length or true size. We call it natural size sometimes. And also and it also has like three main locations. This is horizontally level plane. If it's parallel to OX line, it will be horizontally level, because this depicts the elevation, and I'm looking at the plane and I see just an edge. That means all of the points will be equal height, so that gives me the level plane. It can also be down here, but instead of 1, it will have, instead of 2, it will have 1, which means I'm looking at this thing from top, and this is the wall. This represents the wall or back wall or frontal projection plane when you are working in the plan. So in this case, I'm looking at something which is an edge view of a plane, and it has the same width from the wall. All of the points are have the same distance to the wall. In this case, that's also a level plane, and everything contained here, any figure drawn here, will be with its natural undistorted size. So that's that out of the way. We can move on to level lines, which are quite important. First, let's discuss the belonging, which is quite an important topic as well. So we know when, or what we call the belonging. If the point belongs to the line, it is resting on it, okay? And when it comes to the planes, you can attach the points or the lines. It's up to us. If I draw a line like this, okay, and we call it a name, maybe M2, but smaller case. Now we need to find its, if we are told, first of all, if we are told that line M belongs to plane ABC, we need to depict it accurately in horizontal projection, because we cannot draw any line. Like I can draw this line and call it M2 and it M1, and it will be incorrect because it doesn't belong to it. Well, it may, but we need to find it. This line, if it's resting on this plane, has infinite amount of common points, like this one, this one, this one, this one, infinite amount of them. But to depict it simply, I'm going to use one that is quite easy to find down here, which is the intersection points here and here. Let's call it intersection just to make it simple, because that's not really an intersection. So let's mark the points here and here. We can give them names. Let's call this one 1, 2, and let's call this one 2, 2. And now we need to pay attention at something. Point 1 is resting on AB edge here, or side. Likewise, its horizontal projection should also be resting on AB. So let's just project it down here. Likewise for point 2. There you go. And let's mark the points here and here. And also let's give them their respective names. 1, 1 and 2, 1. Like this. And since line M was defined by the points 1 and 2 here in frontal projection view, it's going to be defined with the exact same points. So if I draw a line going through both of them, which is this line here, we get an accurate depiction of line M, which belongs to this plane. Okay, that out of the way, let's now move on to when there is a level line, because it's slightly different. And as we know from the previous lectures and practicals, there are three main level lines, which is the frontally level line, horizontal level line, and profile level line. Most of the time we will be using horizontal and frontal. Like I've really never had a scenario when I had to use the profile line. But yeah, it's good to know that it exists. And every plane has its horizontal and frontal lines, if it's an oblique plane, of course, because some other planes may not have it. And let me just take a different color. And we have, in this case, now we don't have a profile projection, and so I'm not going to draw profile level line or profile line. In this case, we will have a horizontal line and a frontal line. And they have quite a nature. If you remember, they are always parallel to X line here. In horizontal projection view here, in the plan view or the top, frontal line is always projected as parallel to X line, and vice versa for the horizontal line. It is always parallel here, because you want, just like the planes, horizontal level plane being parallel to X line here, which represents the ground in frontal projection. This is one of the key factors here. If you realize or visualize that X line represents the ground in the frontal elevation, and it represents the wall in the horizontal projection, this subject becomes really simple. So we can draw any number of horizontal lines like so, like any of them, and we can attach like any of these lines and find its projections down here. But if to find the horizontal lines, they must be drawn as parallel to X line in the frontal projection. You cannot figure out where it is here. It's just impossible. It just doesn't work. But this is a lot of work to do. We have to find 2 points, find its projections down here, but again, that's like 4 points I have to mark. But let's not make it harder for us. We can simply draw a horizontal line coming from one of the points. In this case, point A is the most convenient, because if I had drawn it from point C, and I can say that it belongs to this triangle, or the plane which is defined with this triangle, but there is one problem. I do not have any other edge where I can make it belong or attach it, right? In that case, I would have to elongate this one out here, attach it, and since it is the BA or AB elongation, it should be somewhere here again on AB elongation. So let's not waste time there. In this case, let's just use this horizontal line. And again, we have to mark only 1 point instead of having to mark 2 points there. Let's find its projection. Since it was on BC, it should be on BC here as well. So we got this. Since, well, let's just call it a name. Let's also give it a name. All right. Since this horizontal line, which has a name, always has a name of h, small case, smaller case or lowercase h2 in this case, and in the frontal it was parallel, but here of course it's inclined like this, and in the horizontal projection we will call it h1 like so. Okay, and what if we want to find another horizontal? Well, it's really simple. Maybe from here, going through here, right, like this. Maybe I wanted to find this one to begin with. Okay, again, we need one more point. Let's make this point, I guess. But I only need 1 point. I do not need this point anymore, and I'll show you why. By the nature, these are both belonging to the same oblique plane. And in the horizontal projection view, they will appear parallel, like this. And just to prove it to you, if I had drawn this point down here, it intersects here. So if I define this line by these 2 points, here and here, yeah, I would have got the same line. Like no matter how many horizontal lines I draw here, I always get parallels down here. All right. So I'm going to erase this for now, like this. And now for the frontal. When it comes to the frontal, well, we can draw it from here. It's exactly the same procedure, but in this case, we are working in reverse, like in mirror. It's more correct to say it like that. The frontal line is always parallel to X line in the horizontal projection view. So let's simply take it. Again, I used this point. I could have used this point because I have it already defined here. It's up to you, really. But we need to give them names. And when you have connection lines, they should never be crossing letters and numbers. So this is what happens in that case. Okay, let's give it a name. And this should become F2. I mean, I avoid writing them in there because I don't really like it. Up to you. It's not a mistake, but I saw. Okay, that's the setup. And we drew the horizontal and frontal lines, which are the level lines belonging to the center plane. Now let's use the same plane and try to locate a point on it. Okay, I changed the setup slightly. I changed its, or I made this so its horizontal projection is slightly different because I want to demonstrate something that I will get to. And in this case, we are given point D, and we are told that point D belongs to triangle ABC or plane ABC. We do it in the same way. We need to attach it somehow. I'm going to use different color. We can attach it to any edge here. I can also use this kind of line, this kind of line. Only rule of thumb is, or only criteria is that the line should be going through point D, and it should theoretically, and we need to tell it to ourselves, it also belongs to this plane right here. So in order to make it convenient for us, I'm going to use already existing and designated point, which is A, B, and C. In this case, I'm going to go with point A again. Draw a line going through point D and elongating it until it cuts here. So now what I'm told is that point D is somewhere located on this pink line right here. But I need to find that pink line somewhere. And also what I know is point D will always be on the connection line here somewhere. But I don't know what kind of width or y coordinate it has. I have no clue about that. But I know enough information to find it. Let's first mark this point, call it a name, maybe 1, 2. And obviously, and when you come down, the reason why I changed it, I have an urge or temptation to just stop here because I found its connection, right? I found its projection down here. No, because point 1 is contained or resting on BC. And when I come down here, find its projection, well, I have done it, right? No, because this point right here doesn't represent point 1 at all. If it belongs to this triangle, that is. That is because point 1 here is resting on BC. What I did here is I taken it on AC. That is incorrect. So I have to move it down, even though it was kind of tempting to stop there. Well, no. I have to find it here. That's the accurate position of point 1 in horizontal projection view, or the projection of it. Point is always fixed. Now we can define this pink line like so. And what I knew is that point D is contained on this pink line or purple line, and it is also being contained on this connection line. So let's find the equation which satisfies the both or the point. So it should be somewhere alongside this and somewhere alongside this. Well, to satisfy the both criteria, it should be here. That's the only point which satisfies this, right here. And that's the projection of D. And now, just to show you, If I had used any other point, again, this is AC, it should be right here, and drew the same thing, as you can see, it crosses in the same point because this subject is really accurate. It doesn't make mistakes. Okay, so that's all I wanted to say about depicting an oblique plane or any plane in the space. And then on the projections, that's really the main one of the main subjects of descriptive geometry. If you start real good from here, it's going to be quite easy to continue on the next subjects, which really builds up on this foundation that is depicting a plane and its relation with the point and lines, and most importantly, level lines. So if you have any questions, feel free to ask me. I'll try to record another video, or I'll try to explain them the best I can. So yeah, this was it for now. See you next time.